Hey everybody, let me spend a little bit of time talking about how to go about doing some of the calculations for experiment 22 in Chem 118. Remember that in the lab you should have had 8 samples in the spectrophotometer. And here's the data on all 8 of those samples right here. And we are only concerned with the samples for the calibration curve 1, 2, 3, 4, and 5. Okay. Now each of these calculations will be the same, but you'll have to substitute in the correct number from each column. So what we need to do in order to calculate what the current concentration is we have to use the dilution formula, and that's what is right down here. Okay. So when we made our solution for sample 1, you can see the data right here. Okay, we used 0.3 milliliters of a solution that was 0.025 milligrams per milliliter. And that's going to equal 10 milliliters. That's what we diluted it to. And that's going to give us our new concentration here. Okay, so when we do our math and do our mental, maybe not even mental, but when we do all our calculations, we are going to get an answer of 0.00075. Okay, in scientific notation, that's 7.5 times 10 to the minus 4. Okay, and the units on that are strange concentration units, but this is what medicines use for concentration, so it's in milligrams per milliliter. Okay, so you're going to use this same outline for all 5 of these concentrations, right? They're all getting diluted to 10, but they all starting with a different volume here with the same concentration. So the only thing that's going to change in each of these is this number right here. So the next one will be this, okay, and then it'll be this, okay? Once you get that, you need to go to a graphing utility, whether it's Google Sheets or Excel, and you need to put the data in the graph. So let's go there. I have the information about the absorbance entered here into just a simple data table, but I need to take the concentration that I just calculated for each sample, 1, 2, 3, 4, and 5, and I need to put that in here. So spoiler alert, these numbers should be the same for everybody. Nobody has any different numbers here for the concentration. What will be different is the absorbance here. Okay, so this is the absorbance that I got from the lab. Okay, you did each of these things. Okay, so what you're going to do in your graphing utility, okay, is you're going to highlight the data, and then you're going to make a chart. The chart you're going to make is going to be a scatter graph. Okay, and I'm using Google to come up with the scatter graph, okay, or the scatter chart. And in order to get the data on the scatter chart, you're going to have to go to Customize, you go to Series, and you will see that there's a trend line, and you can add the trend line, and then it says Show R-squared value. So while I'm in the series here, I show R-squared value. I'm also going to do data labels. Okay. And I'm going to get rid of the custom label for the R-squared value. And then I'm going to, on the label, I'm going to click Use Equation. And so that's going to get the label here where I have the equation of the line 208x plus 0.0864 equals y. So now that we have the equation and the r-squared value, the r-squared value only tells you how good the data is. It is not useful in determining the unknown. So the closer this is to 1, the better your data is. So this is pretty good data. Okay, so let's go back and use this equation to figure out what the concentration of our known and unknown is. Okay, so this is the equation of the line. Now keep in mind that the data for us, remember x, the x-axis for this was concentration, and the y was absorbance. Okay? So, and you'll have 2 pieces of data that you need to plug in here. For me, my unknown had an absorbance, so a y value. My unknown had an absorbance of 0.237. So because that's my absorbance, that's going to get plugged in here. So we plug this in, we get 208x plus 0.0864 equals 0.237. Okay, so now you can solve for x, and keep in mind x is your concentration. And when I do that math, I get x equals 7.24 times 10 to the minus 4, or if you don't do it in scientific notation, 0.000724. And that was for my unknown. Then you can go to the lab and you can do the data analysis pretty straightforwardly following the steps in the lab. For the unknown here, step 1, we just figured out what this was from the unknown. And then you can obviously multiply by 10 and divide by 5. That has to do with the dilution. Remember, you took 5 milliliters of it and diluted it down to 10. And then you originally had 50 you had 2 milliliters of it and you diluted it by 50. And so this is going to give you how many milligrams of iron you have. Okay. And then keep in mind that you crushed it up. So now that you have the milligrams of iron, then you're going to divide it by the grams in the beaker. And this is going to give you the milligrams of iron per grams used. Okay. And then you can take that number here, the answer from here, and plug it into here and multiply by the mass of the pill, and that's going to give you the mass of the iron in the whole pill. Okay, and so then your job is to do this also with the known sample so that you can compare the known sample to your unknown so that you have, as it says here, you know, the results seem good. You have something to actually compare to. Okay. So that's how you're going to end up writing up this lab. Okay? So hope this helps. Have a great day.